Okay, I'm going to put some of this, those 4 other videos together to make sense of it and how you use those ratios and those triangles and the unit circle to find exact trigonometric ratios of sine, cosine, tangent, cotangent, cosecant, secant, all those. Okay, so let's say we wanted to find the sine of 330 degrees. So think about a unit circle here. And 330 degrees, where would that be? First of all, what quadrant is it in? And you say, the 3rd quadrant. Yeah, that's right. So 330 degrees, you'd come all the way around here, right? And you'd come to 330 degrees right there. This would be 330 all the way around. Like this is 330 right there. What does that leave you in this triangle? 30 degrees, right? So if you're drawing a reference triangle for this, here it is. 30, 60, 90 triangle. That 30 degrees right there is the reference angle that we're using to find this answer. You got to get this, okay? 30 degrees is giving us the answer to the 330. This triangle that's built around the 30 degrees, the reference triangle, determines the answer for the problem that you're trying to find. You need to figure out what that reference angle is. You get 30, you get 60, you get 90. Across from the 30 is 1/2, right? Across from the 60 is root 3 over 2. However, this is negative 1/2. So this coordinate would be root 3 over 2 for the x, negative 1/2 for the y. Now the question is, what is the sine of 330 degrees? Sine, as you know, is opposite. In this case, from this 30 degrees, opposite is the negative 1/2, right? Sine is opposite over hypotenuse. The opposite of 30 degrees in this problem is negative 1/2. The hypotenuse is 1. The hypotenuse on the unit circle is always 1. Well, what is negative 1/2 divided by 1? It's negative 1/2, right? What we just found is that the sine of 30 degrees equals negative 1/2. My calculator here is in degree mode. Where is it? Whoops. My calculator is in degree mode, and I am going to find the sine of 330 degrees, and it equals negative 0.5, negative 1/2. I'm not very good at this, but there you go. That's pretty cool. Now I want you to notice that the sine of this 330 degrees is the second number in the coordinate. That is an amazing thing right there that we're going to continue to use. I'm going to do a cosine one now. So this works for all angles on a unit circle. Remember that the angles on a unit circle are generated from 30 degrees and 45 degrees, and it takes you all the way around that circle. So if I said 225 degrees and I want to find the cosine of this, the cosine of 225 degrees, cosine of 225 degrees, that puts me 45 degrees past 180. This is 225 degrees. This is a 45 degree angle. 180 plus 45 is 225. I draw my triangle in here. I know that this is 45, 45, 90. So across from the 45 is root 2 over 2. Across from the other 45 is root 2 over 2. And of course the hypotenuse is 1. Now remember that this one is negative. Well, and this one is negative. Because we're in the 4th and the 3rd quadrant here, they're both negative. So this coordinate out here is negative root 2 over 2, comma negative root 2 over 2. So the cosine of 225 would be cosine, adjacent over hypotenuse. SOHCAHTOA, right? Adjacent, negative root 2 over 2 over 1. That's just equal to negative root 2 over 2, isn't it? That is what the cosine of 225 degrees is. Now, if you do that on a calculator, since we're in degree mode, and I do the cosine of 225, is what I get. Negative 0.707, whatever. There you go. So, is this right? Well, I think it is. So let's check. We can make a fraction out of here. Go to negative the square root of 2 on the top. And on the bottom, we just put a 2. And you get the same thing. So it's correct. It's an exact answer. When we're doing trigonometry, you want exact answers. Now I want to show you one more here, maybe more than one more, but let's say we wanted to find the cosine of something off of 30. So 30, 60, 90, whoops, drop something. 30, 60, 90, 120, cosine of 120. Okay, that's 30 degrees off of 90, so you're right here. This is 120 degrees right here that I just drew. That means when I draw my reference triangle here, what is this angle? Well, it's 60, right? Because 60 plus 120 is 180. What is this angle? 30. What's opposite to 30? 1/2. But that's going to be negative because we're right to the left of the axis. What's this length across from the 60? Root 3 over 2. So what's this coordinate? Well, negative 1/2 is the x. Root 3 over 2 is the y. What's the cosine of 120? It's adjacent over hypotenuse. Negative 1/2 over 1. Well, that's negative 1/2. I want you to notice that this coordinate has an x value of negative 1/2. So I'm going to make this one grand statement here right now. This is important. The coordinates on a unit circle, there's an x and a y, right, all around the unit circle. They're all over here. Sometimes the x is positive, sometimes the y is positive or negative or whatever, depending on where you are. Well, here's the thing. The x value in the coordinate is the cosine of whatever your triangle, wherever your angle is that you're trying to find. If I want to find the cosine, which I just did, of 120, the answer was negative 1/2. That was the x value of the coordinate at 120. Don't miss that. That's big news right there. The y value is going to be the sine. The only sine one I did today was down here. I think it was 330. What was the sine of 330? It ended up to be 1/2. Right? It was 30 there, so it was across from the 30 was 1/2. This was negative. This was root 3 over 2. Actually, so it was negative 1/2. The sine was negative 1/2. Well, the coordinate here was negative root 3, or was root 3 over 2 comma negative 1/2. The second number here, that was the sine. When you're dealing with a unit circle, the first number in the coordinate is the cosine of that angle, and the second number in the coordinate is the sine of that angle. If that makes any sense, hopefully. Let me try to make a little bit more sense of it here. So you've got a unit circle. On that unit circle, there's coordinates all over it. There's a coordinate here. That coordinate is root 3 over 2 comma 1/2. It happens at 30 degrees, or pi over 6. Then you got 45 degrees, root 2 over 2 comma root 2 over 2. That's 45 degrees. Then you've got 60 degrees. That's 1/2 comma root 3 over 2. And then you've got all these other ones over here that I went through. Watch the video again. I went through all of them. All of these coordinates, you can reflect them. So this one's negative 1/2 comma root 3 over 2. I don't have time to do all of them, but this one is at 120 degrees. Here's the question. What's the sine of 60 degrees? Sine of 60 degrees is the second number here. Okay, it's root 3 over 2. What's the cosine of 45? The first number is the cosine. Again, it goes like this. Cosine is the x, sine is the y. What's the sine of 120 degrees? Here's 120 degrees. The sine is root 3 over 2. What's the cosine of 120 degrees? Negative 1/2. What if you're down here? This is negative root 2 over 2 comma negative root 2 over 2. It's 225 degrees. What's the sine of 225 degrees? Negative root 2 over 2. What's the cosine? Negative root 2 over 2. What if you're right here? This is 210, right? What's the sine of 210? Well, what's the coordinate of 210? All I need to do is look up here to get that coordinate. It's lined up with the x, so it's 1/2 for the x, negative root 3 over 2 for the y. What's the cosine of 210? 1/2. Cosine of 210 equals 1/2. What's the sine of 210? Root 3 over 2. Negative root 3 over 2, we should say, obviously. All right, that's key. That's big stuff right there. These are long videos. It's a lot. I would be teaching you for this for weeks in school. Okay, what about tangent? I can't come to the door right now. I'm busy. Who is it? Who is it? Yeah, I can't come. I'm teaching. Okay? Tangent is opposite over adjacent. Right? Okay, well that's great. But we also know that tangent equals the sine of an angle over the cosine of an angle. This is called an identity. Tangent of theta equals the sine of theta over the cosine of theta. Now the reason that that works is because tangent is opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Remember what we call this? The sideways desk or the bridge or whatever you want to call it. The phone, the old phone, all that. Remember all those good times. It makes you miss school, right? If you go like this and you go like this, you end up with opposite times hypotenuse over adjacent times hypotenuse. Well, the hypotenuse is a like term. You can cancel those out. What are you left with? Opposite over adjacent. This is proof that the tangent of theta equals the sine over the cosine. And what does that mean? There's a lot right there. Take a picture if you need it. On a unit circle, if I want to know the tangent of an angle, what if I want to know the tangent of 150 degrees? Well, I just said that it equals the sine over the cosine. So what is the sine and the cosine of 150 degrees? Here's 150. What's that reference angle? You should say 30. That makes this a half. That makes this root 3 over 2, but negative. What's this coordinate right here? It's negative root 3 over 2, comma, 1/2. Okay? What's the cosine? This. What's the sine? This. What's the tangent? Sine over cosine. 1/2 is the sine over the cosine, negative root 3 over 2. Old phone, bridge, whatever you want to call it, you get 2 over negative 2 root 3, which equals 1 over root 3, but negative. You shouldn't leave the answer like this, so it ends up timesing it by root 3 over root 3, and you get negative root, excuse me, negative root 3 over 3. Sorry, I didn't die. I just need a drink of water. Anyway, so that's key. That's good stuff right there. I just found the tangent of 150 using a unit circle. Really using reference triangles and angles in a unit circle. Okay, there's one last thing. These videos are long. There's a lot going on. What about the quadrantal angles? These ones pose some problems. Right here, this coordinate is 1, 0. That's 0. So if I asked you what's the sine of 0 degrees, well, the sine is 0. What's the cosine of 0 degrees? That would be 1. The cosine of 0 degrees is 1. What about this one? This one is 0, 1. What's the sine of 90 degrees? 1. This second number is the sine. What's the cosine? 0. The cosine of 90 degrees equals 0. 180. The coordinate there, what is it? Negative 1, 0, right? So what's the cosine of 180? Negative 1. My video's still working? Yeah. What's the sine of 180? 0. Okay, 270. 0, negative 1. What's the sine of, or cosine of 270? 0. What's the sine of 270? Negative 1. You don't believe it? You just use a calculator. Those are easy ones. So sine of 270, if you're in degree mode, negative 1, right? That's right there. That's the sine, the second number. Very good stuff there. Now, tangents become a problem here, because if I say, what's the tangent of 90 degrees? This is right here. Tangent is sine over cosine. So the sine is 1. The cosine is 0. The tangent of 90 is 1 divided by 0. It doesn't exist. You can't have 0 on the bottom. So we would say that the tangent of 90 degrees is undefined. Okay, what would the tangent of 180 degrees be? Tangent of 180, sine over cosine, 0 over negative 1. That's not a problem. The tangent of 180 degrees would be 0, because 0 in the numerator is not an issue. Don't you guys miss all this teaching stuff? Math is very mathy. So I have a song for this. You guys missing songs, right? It goes like this. 0, 1, 0, 1, 0, undefined. 0, negative 1, 0, negative 1, 0, undefined. Now, I just did jingle bells with that, right? 0, 1, 0, 1, 0, undefined. 0, negative 1, 0, negative 1, 0, undefined. This is what that means. You've got the sine, the cosine, and the tangent. We've got 0 degrees, 90 degrees, 180 degrees, and 270 degrees. The sine of 0 degrees, I just went over this. This coordinate right here would be 1, 0, right? The sine of 0 degrees would be 0. It's a second number. What is the cosine of 0 degrees? That would be 1, right? What's the tangent of 0 degrees? Sine over cosine would be 0 over 1, which is 0. Okay? What about 90 degrees? 90 degrees is right here. The coordinate is 0, 1. So what's the sine of 90 degrees? 1. What's the cosine of 90 degrees? 0. What's the tangent of 90 degrees? Undefined. What about 270? What, 180, I mean. 180 is negative 1, 0. Negative 1, 0, what's the sine of 180? The second number is 0. What's the cosine of 180? Negative 1. What's the tangent of 180? That would be 0 over negative 1. That's 0. What about 270? Whoops, 270. Point to the wrong thing. This coordinate is 0, negative 1. Okay, so the sine is negative 1. The cosine is 0. And the tangent would be undefined again. Okay? Let me get rid of this. Here's my song one more time. 0, 1, 0, 1. Whoops. How come I messed it up? 0, 1, 0, 1, 0, undefined. 0, negative 1, 0, negative 1, 0, undefined. This chart here, the song isn't really that critical, but it is kind of cool. It goes sine, cosine, tangent of 0, 0, 1, 0, 1, 0, undefined. Tangent of 90, undefined. 0, negative 1, 0, negative 1, 0, undefined. Tangent of 270, undefined. Now, if you don't like that stuff, I don't know. You got to get your priorities straight. Anyway, I love trigonometry. This stuff is meaty as heck. It's all meat, not milk. This is hard stuff. It's hard to get. Hopefully my videos helped. If not, let's zoom. Bye.